I currently work at Sky, and my talk will be basically about package management in Node.js. And I feel really bad because I feel like 50% of the talks so far have been about how awesome NPM is, and this talk is going to be the exact opposite. I apologize for that in advance. So I think currently package management in Node is kind of broken. My talk will be basically about how I think we can fix it. So about 6 months ago, really, I started getting annoyed with NPM's performance. And in fact, I started getting annoyed so much that I tried to tear it apart and look what it was actually doing. And at that point, I realized that it's actually a really complex problem. But I thought that the NPM approach overall could be improved upon. So originally, the main motivation behind this project of trying to replace NPM was really NPM's performance, which was, at that point, was NPM 2, and still is, with NPM 3, pretty bad. And also unpredictable in certain cases. For instance, there was this case of a progress bar, where the progress bar was actually slowing down installation noticeably, which I think is a good indicator for that. Also, the problem with NPM 2 was that it was installing redundant dependencies, and I will go into more details later on. And in some sense, I think it tries to do too many things. NPM should really be about installing dependencies and nothing else, ideally. Ideally, you would want a separate tool for anything else, I think. And it's also hard to debug, and NPM 2 just consumes a lot of disk space, and don't like that either. So as I mentioned, originally I tried to replace NPM, and that really, the first iteration for that wasn't too hard. Was trying to recreate the NPM 2 installation mechanism, which is essentially like a nested dependency graph, which is problematic on the Windows, as mentioned before, because the maximum path length is limited on the Windows. And it actually went pretty far along, so it was able to install its own dependencies, so it was kind of bootstrapping, more or less. It supported Semver, circular dependencies were handled correctly, and worked with about 60% of the packages that were hosted in NPM, roughly speaking. And it was pretty atomic. And by that I mean it either worked or it blew up completely and didn't modify your node modules at all. And when doing that, I didn't have an initial benchmarking case, really. But I tried a couple of scenarios, and it turned out to be about twice as fast as NPM at that point. And at that point, I really started wondering, because I didn't have any caching at all at this point. So that's why a couple of months later, I turned this project, which originally I called NPM, which was a pretty bad name. It's getting worse. I started writing this project called IED. So IED really tries to be a complete NPM alternative and replacement. And the goal really is to concentrate more on the core functionality that NPM provides, which is installation of packages. So when I use NPM, I pretty much only use NPM install, because that's the only thing I'm more or less interested in. It also has a working progress indicator and works with NPM together. So of course, there are features in NPM that are awesome that some people use, and so you can use them with IDE as well. So that project started getting some traction initially, and there are currently quite some people using it, actually. So that's why I started kind of investigating the whole NPM issue further. So maybe a little bit about the current state of IED, and then I will go into detail why it's actually faster. IED at this point supports most of the awesome features that were mentioned previously that NPM supports. So it supports lifecycle events such as start, post-install, pre-install, things like that. IED init is also supported, uses actually the same mechanism that NPM uses, so NPM is really awesome in that regard. It also has a new command called IED-sh, which allows you to actually populate your current path with the modules that you installed locally in your current package. So for instance, when you install gulp locally, you can actually just run IED-sh. It will then populate your path, and you can execute gulp as if you would have installed it globally in that project. There is also, of course, IED install, which is the exact equivalent to NPM install. It works quite differently, but has pretty much the same effect. There's IED link, which is the exact which pretty much does the same thing that NPM link does. There's IED build, which builds your dependencies, which is also more or less the NPM equivalent. There's IED ping and pretty much all, like, majority of other commands. except one, which I will go into more detail later. It also supports private registry and scope modules. So in that regard, it's pretty much the same. So I want to give you a quick demo, really, and I was afraid of not being able to demo it because of, I don't know, I was just afraid. Let me quickly show you how it actually looks like to install Express. This is without any caching and with a pretty good internet connection. But installing Express using IDE on this machine takes about like 2 seconds, which is significantly faster than NPM. So if you want to try it out, of course, all benchmarks are flawed. But I made one. Browserify is really a great example for that because Browserify itself is extremely modular. It has a lot of transitive dependencies that depend on each other, and they're like circular dependencies. And it's just a great example for really trying out how fast the package manager really is. So this is, of course, a flawed benchmark, as all benchmarks, but you can try it out your own. In this case, to show you that I didn't cheat, I enabled silly logging levels, like as a log level on NPM. ID is already done, NPM still takes time. And yeah, you see the point. I want to go into more detail why ID is faster than NPM, or specifically why ID install is faster. And the main reason is primarily because the control flow is quite differently. And in order to manage that, RxJS is being used. So pretty much everything in IDE is written in Rx. Rx, for those who don't know, are the reactive extension for JavaScript, which is a project for dealing with reactive streams, the observables and that kind of stuff. It's really nice. I'm not going to go into detail how that works specifically. I'm just going to show you some code later. And that's essentially the core implementation perspective and difference between NPM and IDE, I think. And also what's quite different is symlinks are being used instead of having some crazy NPM node modules directory structure. So they're flattened by default, and it only supports toggles. So that's a fair point that NPM supports Git dependencies and like can install from pretty much everything. GitHub gist. IDE doesn't do that, and that's by design pretty much. It only concentrates on toggles because that's really what a package manager I think a node should be primarily about, at least at this development stage. And also it concentrates on optimizing startup time. So the way you organize your node modules directory actually also impacts the startup time of your application. So if you have like a crazy nested node modules structure where you rely on like parent dependency somewhere over there, it actually can impact your startup time. So managing node modules. So let's look at npm2. If you run npm install npm2, you get a dependency graph that looks something like this. You have node modules. It's extremely nested, which causes problems under Windows with the maximum path length that you might exceed. But it's pretty predictable, right? So you have Express, which depends on accepts, which depends on types or something, and so on and so forth. So it's nested, but it's very predictable. npm3, by contrast, is flattens your dependency graph, which is like awesome, like in a sense, but also causes some problems. Because now at that point, when you're installing Express, you might actually end up requiring a final handler serve static, because there's no difference from the perspective where you're requiring it, whether or not you know that it is actually installed, like installed as in like explicitly installed, or if it's like just some other dependency that depends on it that might then remove that dependency. So in that sense, I think it's problematic. So for instance, serve static, you can totally require serve static in here. It totally works, but it really shouldn't. And this tree flattening algorithm that NPM uses also is like pretty expensive actually, and also complicated, and I don't think we need this. So what IDE does instead is it creates symlinks. So the entire mechanism of installing dependencies is split into 2 parts. First fetching them, 3 parts, resolving them into their subdependencies, fetching the actual toggles, and linking them. So by explicitly creating symlinks to reference dependencies of dependencies, it pretty much eliminates all the complexity associated with this tree flattening, which is at this point no longer needed because you're guaranteed to always have a completely flat dependency graph. So the way this works is when you look into the Node modules directory after you ID installed something, you just see a symlink. So when I ID installed Express, for instance, I see a symlink from Express to a directory cast dot and then some random checksum and then slash package. So this is very different from NPM. So first of all, this has the advantage that under Windows, you don't run into the problem of having very long path names because they're all only like one level deep, really, always. And it's also more predictable in the sense that if you delete random directories and you just run ID install ID, will just repair it and it will just work. And it's also slightly faster because there's no fallback between node modules. So when you place a nested dependency in NPM2, the way it resolves circuit dependencies is by falling back to the parent, which is no longer needed that way. So I mentioned this cast directory, and the way this is organized is dependencies are being referenced by their contents as opposed to their name. So when you look into the node modules directory after installing Express in NPM, you see a directory called Express, and what's in there is Express. ID does not do this. Instead, you have a symlink which references a package which can be identified by checksum. So for instance, Express might be in this 518F9 whatever directory, which itself contains a directory called package. And that's where the actual extracted tarball is located. In this node modules directory, you then have symlinks to transitive subdependencies. So for instance, Express, which let's assume that's the first dependency over here, might have a dependency on debug. Debug then is being referenced using a symlink as opposed to an actual directory. And that actually simplifies the installation mechanism quite a bit. Also, it might look unintuitive if you just look at the directory content itself. That's the reason why those symlinks to Express are being created in top-level directory. And this is hidden in like a contradecimal storage. Very similar to Git in a sense, which does pretty much the same thing. So I mentioned this identification by chasm as opposed to their package name. So when you install a package Express 4.14.0, the name, the way ID actually references package is by chasm, which in this case is C1E3F, whatever. And it's not being referenced by its name, which is Express. And there's really one main difference on how these packages are being resolved between NPM and ID. NPM2 at least always hit the package root URL, which contained all possible versions of a package, all possible package JSON versions of a package when resolving that specific version. ID actually doesn't implement semi-really. Instead, it just hits the registry and lets the registry resolve it. So in this case, it says, OK, give me Express, give me the latest version of it, /latest, which is common.js registry spec compliant. Another reason why it's fast is because it does everything at the same time, really. Essentially, it does a request to resolve Express to its latest version, and then gets back a bunch of dependencies, and then it just does everything. And what might happen is that you end up installing Express, as in fetching the tarball, linking it, whatsoever, after actually fetching the tarball of its subdependencies. So in that sense, the order becomes unpredictable and slightly harder to manage, but it comes with a really significant speed improvement. And so I mentioned how it's actually harder to kind of manage the control flow and how I'm using Rx for that. And so the way this works is really nice because you can implement the steps of the installation as custom operators in Rx. So your installation is really just kind of like a pipeline, an observable of dependencies that just come in over time. And then you map over them, you resolve them, you download them, and then you somehow link their dependencies together. And the nice thing about Rx really is that that becomes really easy to benchmark and test, and those custom operators can be just plugged in. Like for instance, ID can install from GitHub, can also install from tarballs, as I mentioned earlier, and from just any private registry. And those custom installation mechanisms can be really just custom operators that you write on your own. And then you can just plug them in and just work. So it's quite modular. There is one part about registry, about NPM as a system that I want to talk about, which is publishing packages. So one of the most requested features on ID was the ability to publish packages. And that has intentionally not been implemented because it's quite easy to implement. It's just packing a tarball and then uploading it. So the reason this doesn't exist really is because I think there is an overall larger problem with the way the NPM registry works. I think the NPM registry as a whole is just a completely different ecosystem. You NPM publish stuff to it and just host it, which is nice and makes sense, right? But on the other hand, almost all dependencies that are hosted on NPM are also hosted on GitHub, at least the open source ones. So I would say so. The overall majority of dependencies definitely hosted on GitHub. I checked. Definitely.
It's much faster to do it through a registry than on GitHub.
Exactly, that's what I'm going to talk about. The main advantage of having this NPM registry is performance. So I want to introduce kind of like a different project. So the first idea behind this whole IDE project was making NPM or the installation mechanism of installing packages faster. But then I realized that actually there might be maybe an idea of introducing a completely different ecosystem for installing packages altogether. So as I mentioned earlier, those like the registry for hosting packages and GitHub live in completely different worlds. And what I think should happen as opposed to enforcing you to NPM publish packages is a registry should synchronize more or less from GitHub, for instance, your packages and more or less like ingest them. So this is pretty much what the second part is about, really. So I want to briefly go over this. I started writing this project called Nerva, which essentially acts as a mirror for GitHub. And the whole idea behind this is to introduce kind of like a proxy for installing dependencies, as opposed to having a completely isolated NPM registry that has nothing to do with GitHub. Nerva dynamically builds tarballs just as the NPM registry and caches those from some arbitrary Git repository. So that's really handy if you host your own like 5 packages or something. And that's really what I want to mention briefly. That's the first part. And the second part is, so what was also mentioned is license management with NPM and NPM Enterprise. So one of the future features of NPM will be the ability to conditionally review dependencies and approve their licenses. Because after all, you want to have some visibilities of what you are actually installing on your machine. And that's what ID Stormtrooper will be about. So currently, what you're able to do at this point is approve dependencies conditionally and just check whether or not you agree with their licenses and review their code. But eventually, there's going to be kind of like a replacement for locally reviewing dependencies manually and speeding this whole process up. So I'm actually 2 minutes faster than I planned. So maybe just to give a quick summary, you can get ID and a few of the stores, of course, on GitHub and Nerva as well. And what's wrong? And yeah. And NPM is awesome. And thank you.